This time I'm not asking for specific things like amplitude, phase shift, period, all that good stuff. So make sure you can find all those, but when I go to graph, what's really important, the amplitude is definitely important, how tall the graph is. Phase shift is really important because it's how far it's shifted left or right. And ultimately, period's pretty important too because it's how wide one full cycle is. And normally I'm going to ask you to do 2 full cycles on all the problems in the homework and on the assessments. So really those 3 things are what you need to find. And if you find frequency, whether you do that or not, it's not super important, but those are the 3 main things: amplitude, phase shift, and period, to really get the graph done correctly. So let's look at those. I'm just going to find them, write them down. Amplitude, it's the A value, it's 5. The phase shift, actually let's go ahead and do the period, because that's usually not too bad to do. It's just 2 pi divided by your B value, which is 2. So the period here is pi. And then your phase shift, so the easiest way to find that is take what's in here, x, 2x plus pi over 6, and set it equal to 0. So 2x is going to equal negative pi over 6, x is going to equal negative pi over 12. So this thing gets shifted pi over 12 to the left. And that's also the starting point. So I'm going to make a little note, that's the start. Now, if you want to do the ending point, you just figure out where sine usually ends, which is at 2 pi. When this stuff in here equals 2 pi, you'd be done. So 2x plus pi over 6, set that equal to 2 pi, and see what you get. Well, 2 pi minus pi over 6, if this was going to be over 6, that would be 12 pi over 6. So 2x will equal 11 pi over 6 divided by 2, and we get 11 pi over 12. Now, a good quick check here. From this point to this point should equal your period, because that's the beginning to the end. Well, negative pi over 12 to positive 11 pi over 12, that's altogether 12 pi over 12, which is pi. So it's checking out, it's looking good. Where I usually begin, I take that starting point, which in this case is negative pi over 12, and then I put that ending point, which in this case is positive pi or 11 pi over 12. And I get that on there. And really it's just about finding endpoints. And this is what typically is the toughest part I've found for students graphing. But if you just find midpoints, I think that's the easiest thing to do. So I think midpoint formula, if you get stuck, some people can just do this without really doing a whole lot of work. They're both in 12ths, so I'm really going from negative 1 to 11, and I'm finding what's halfway in between. And to do that, I just add them together, divide by 2. So that would give me 10 divided by 2, which is 5. So 5 pi over 12 is right in the middle. And then you got to find what's halfway between each one of those. So, well, from 5 to 11, halfway between 5 and 11 will be 8 pi over 12. 8 pi over 12 reduces to 2 pi over 3, so you can make that reduction. So if I find the midpoint between these two, negative 1 plus 5 would be 4, divide that by 2, so that's 2 pi over 12. And 2 pi over 12 divides or reduces to pi over 6. So that's one complete cycle. And I'm going to ask you to do 2, but let's get this first one graphed. And then the amplitude was 5, so I want to make sure I go up to positive 5 and down to negative 5. Now, sine wave typically starts at 0 and goes up. The amplitude, or A value, is positive, so we will go up at the beginning. If A was negative, we go down first. So on the endpoints, it's going to be at 0. In the middle, it's going to be at 0, and that's why I think it's so easy if you just get these quarter marks. All right, so normally at the first quarter mark, it'd be up at 1, but this is up at 5. And over here, it would be at negative 1, but this is at negative 5. And that's really all you've got to do to get the main idea. That's really the 4 main points, or 5 main points I'd be looking at for a cycle. Now back here, we went pi units back. That's going to put us at negative 13 pi over 2. If you added another or subtracted another pi away from there. Now, halfway between 1 and 13 would be 7. Halfway between negative 1 and negative 7 would be negative 4. Negative 4 pi over 12 reduces to negative pi over 3. Halfway between negative 7 and negative 13 would be negative 10. 10 over 12 reduces to 5 over 6, so negative 5 pi over 6. And I just realized that I left the 12s off of there. Those are both supposed to be 12s. So now, just kind of doing the same, if this is the end of the cycle, if it started here, it would be at 0. Halfway between would be at 0. Halfway between those two would be up at 5. Halfway between these two would be at negative 5. And there you go, that's a complete cycle. The 2-cycle thing is really to make sure that you get plenty of practice counting and that you're able to handle that part. Let's do one more graph. This time let's do a cosine. We'll find all the same information. We'll start with amplitude, which in this case is 2. Period is going to be 2 pi divided by your frequency. So pi over 2. And then for phase shift, I'm going to go ahead and do that thing where I talk about where it starts. Now, with cosine, you can use the same approach. Cosine of 0 is 1. So it's fine to set this stuff equal to 0, and that's what I find most people like to do. Just remember that the y value is typically 1 when you do cosine of 0. So be careful where you begin your graph. We do typically begin a cosine graph at 0, 1. That'll come up again when we get to the graphing part. So I'm going to do the same approach. I want to know when this stuff would equal 0, how would x need to change? So 4x minus pi over 3 equals 0. So 4x is going to equal pi over 3. X is going to equal pi over 12. So another pi over 12 example. For the ending point, we usually end a cosine graph back at the top, back at 1, when we plug in 2 pi. So I'm going to set this stuff equal to 2 pi. And 4x would equal 2 pi minus pi, or add plus pi over 3. If this was pi over 3, this would be 6 pi over 3. So 4x will be 7 pi over 3. And ultimately, x will be 7 pi over 12. Now, again, quick check. Let's see if the distance between those is equal to what we expected our period to be. Well, that would be 6 pi over 12, which is pi over 2. And that's exactly what we expected, so that looks good. Phase shift is basically the same thing as your starting point, so pi over 12. So let's go down and get this stuff in. Amplitude, I'm going to go ahead and put the negative 2 and positive 2 on the y-axis. All right, I want to start with pi over 12 and end at 7 pi over 12. This is a case where, since I left a lot of room that way, it really doesn't matter how you want to do it. I'm going to go ahead and just make both waves out in this direction. So I'm going to start with pi over 12. I'm just saying that because I want to stop at midway with 7 pi over 12. And while we're at it, I'm going to go ahead and add another pi over 2 to get this is one full cycle, then we'll have a second full cycle. So I'm going to end that at, we got 6 more, 13 pi over 12. And then let's get our midway points. So halfway between 1 and 7 would be 4. So 4 pi over 12, which reduces to pi over 3. Halfway between 7 and 13 would be 10. 10 over 12 would be 5 pi over 6. And getting these points in between here is going to be a little tricky. This will be a place where I'm going to go back to the midpoint. Pi over 3 is really 4 pi over 12. Just to make those easier to do. And I'm finding the average, so I'm finding what's halfway between. So that'll be 5 pi over 12, and we're divided by 2, so 5 pi over 24. So that point's 5 pi over 24. And then in between these two, kind of the same idea, 4 pi over 12 plus 7 pi over 12. And you're taking halfway between. So 11 pi over 12. And you're divided by 2, so 11 pi over 24 is where this one would happen. And sometimes you do get some sort of strange values that aren't showing up on the unit circle, and that's okay, that's just kind of how it goes. Now, to make this a little bit easier, let's look for the pattern. What are we counting by? So if these are out pi over 24s, this will be 2 pi over 24. So 5 pi over 24, this will be 8 pi over 24, 11 pi over 24. So really, I'm just adding 3 more each time. So if this was out of 24, that would be 14 out of 24. So this one will be 17 pi over 24. And then just kind of check. If you did 3 more, it'd be 20 out of 24. So 5 over 6 makes sense. 23 out of 24, that'd be the next one. And then 26 out of 24 would be the last one. And that checks out too. So once you've done a couple of them, really, once you've got the first few, you can usually figure out a pattern and just count by that. But you can always do this midpoint stuff if you need to figure it out. To do the graph, let's go back to our starting and ending point. So we started at pi over 12. Now usually cosine is at 1 when you begin. Amplitude was 2, so we need to start up at 2, which means we need to end back at 2. All right, then cosine, halfway in between, as you do a full cycle, it goes down and down to -2. So I'm going to go ahead and put my -2's in here. And it's at 0 on all the other marks. And I'm just going to fill it in. So down, up, down, up. And that'll do it. That's 2 full cycles. If you want to, you can show some arrows on the end. That's probably a little more proper. But that completes our graph.